Welcome to Study Loop.
For part A of our question, we are asked to find the radius of curvature of the mirror when given the focal length f. So the radius of curvature by definition is equal to 2 times the focal length. So we plug in the value for the focal length and we find that the radius of curvature is equal to negative 20 centimeters. Part B of our question asks us to find the location of the image since we know the location of the object to mirror distance as well as the focal length here. So to do that, we use the equation that says 1 over the distance to the object plus 1 over the distance to the image, I, which is what we're trying to find, is equal to 1 over the focal length, f. Solving this equation for I, we find that I is equal to p times f divided by p minus f. So plug in our values for p and f. Remember that f is a negative value, so make sure you plug in a negative value for f. And we find that I is equal to negative 4.4 centimeters. For part C, we are asked to find the magnification, which we can now do since we know I. Magnification is by definition negative I, image distance, divided by p, object distance. Plugging in those values, we find the magnification is equal to 0.55. So it's positive, but it actually makes the image a little bit smaller, about half as small. Part D wants to know if the image that is formed is real or virtual. So to do that, we just have to look at the value, positive or negative, for I. Since I is negative, but P is positive, that means I is virtual. So we can say that since I is negative, the image is virtual. Part E wants to know if the image that is formed is upright or inverted. To look at that, we just have to look at the sign of the magnification. The magnification is positive, so the image is upright. So we can say since M is positive, the image is upright. And then lastly, part F wants to know if the image that is formed is on the same side or the opposite side of the object that formed the image. So since I is negative and P is positive and I is virtual, it's on the opposite side. So we can say since I is virtual, the image is on the opposite side.